In this video we're going to go over the sine and cosine rule as well as the area of a triangle. We're dealing with non-right angled triangles like this one above, and this is the sine rule and this is the cosine rule. This is a rearranged version of the cosine rule which can be helped in different examples. So if we start, solve the following. So to know which of the sine or cosine rules to use, you can look out for specific things that you're given in the question. So for a sine rule, you need a pair. So one is the angle and one is the opposing side. That makes one pair. You can see we also have another pair, right? So in this case we use the sine rule. We want to make sure your calculator is in degrees as well. So to work out the side x, we can use the sine rule. So it basically means that x over sine 84 equals 25 over sine 47, right? Because you've got the sine of the angle and the side. This can all be inverted across the entire thing, which is what we've done here. We can then rearrange it and calculate for x. So we have 25 over sine 47, and we're multiplying by sine 84. To get 33.99 or 34. Right. The next one. So we have an angle and a side, which is one pair, and an angle and a side, which is another. Take into account that side has to be opposite that angle in order for it to be a pair. So now that we've got two pairs, we can use the sine rule again. So we have x over sine 33 equals 15 over sine 112. We calculate it again. We have 15 over sine 112 multiplied by sine 33. And we're left with 8.81 as that x value. For the next one, we have an angle and a side, and an angle and a side. So as you can see, we have patterns of pairs, and this is all a clear indication to use the sine rule. So we have theta, sine theta over 20 equals sine 60 over 18. And it's the exact same thing as before. To find sine theta, multiply by 20, and then we find the inverse, which gives us 74.2 degrees for theta. For this next one, we have an angle and a side and another side. So with this one, as you can see, we have one pair, but we're not given any other angles. So we don't have any other pairs, which means we can't use the sine rule. If you can see the cosine rule, it involves three sides and one angle. Notice how from this diagram we have C. To find this side, you need B and A, which is here and here, and you need C, which is the opposite angle of the side. So to use the cosine rule, to use this one, you need an angle, and you need to know the sides next to that angle. So here we have 102, and we know the sides next to that angle, so we can use the cosine rule. If we write it, c squared equals b squared plus a squared minus 2ab cosine c. And then if we substitute our numbers, we're looking for x. So x squared equals 22 squared plus 15 squared minus 2. 22, 15 times cosine 102. Right? If we plug that into the calculator, we get 846.2. And don't forget, we need to square root to get an answer of 29. And that's the side. For this problem, we have an angle and a side and two sides. So this is like the problem before, where we have an angle and we know the sides on both sides of the angle. So we can use the cosine rule again. So if we substitute all our values again, we have 23 squared plus 20 squared minus 2 times 23 and 20 times cosine 55. That leaves us with x squared. So we have 401, and then we square root to get 20. For the next one, we have an angle and a side and two sides. So this is cosine again. Using the equation above, we can calculate 6 squared plus 8 squared minus 2 times 6 times 8 times cosine 65, which is 59.4. X equals 7.7. So it's quite easy to identify with the examples you're given, just with what sides and angles you're given, which rule to use. With this one, we have an angle and three sides. Now we don't have any pairs, like pairs of angles and sides, so we can't use the sine rule yet. And because we don't know theta, we can't use this form of the cosine rule. But this form can be rearranged to find theta, given you have all three sides. So another form of the cosine rule is cosine c equals a squared plus b squared minus c squared over 2ba. So you can find an angle given you know the length of all of the other sides. So if we substitute that for this problem, so cosine theta equals 7 squared plus 9 squared minus 10 squared over 2 times 7 times 9. Cosine theta equals 7 squared plus 9 squared minus 10 squared, 2 times 7 times 9 gives you 0.24. Using the inverse cosine, our answer is 76.2 degrees. For the next problem, same again. As you can see, you have three sides and you're missing one angle. So if we substitute our numbers in, we have 15 squared plus 12 squared minus 24 squared over 2 times 15 times 12. Using a calculator, 0.575. So we have theta to equal 125. The next one. So these use the formula to calculate the area of a triangle given you have an angle and two sides. So usually if you were given a bit more information you could use base times height over 2, but you're not always given that information, so we can use this equation. So the area equals a half AB sine C. So a half of 6 times 7 sine 60 to get the area. If we substitute, we get 1 over 2 18.2 units squared. For this one, we have all three sides, so it's not clear how to calculate the area. We could use maybe Pythagoras, but we don't really know how far this could go, so we can use the cosine rule like we used above, because we know all three sides, and we can get an angle. And then once we have the angle, we can use it to find the area. So we can do cosine C. If we label it, we'll know which angle to get. So see, this is C, A, and B. So cosine C equals A squared plus B squared minus C squared over 2BA. So we want to work out cosine C. If we substitute all our values in, we get cosine C equals 9 squared plus 10 squared minus 8 squared over 2 times 9 times 10. That gives us 0.65, so C equals 49.46. Now that we have this angle, we can use half AB sine C to get the area. So you have area equals a half A times B, so 9 times 10, times sine C, which is 49. So plugging that in, we have half times 9 times 10 times sine of the angle, which just gives us 34.2 units squared. And that's it.